Hello, my name is Hannah Hartford, and I'm going to be presenting today on the effects of green tea and lipids, specifically their effect on lipid absorption. Green tea is a very popular beverage around the world. It comes from the tea plant and it carries antioxidant properties. It gets its green color from the inactivation of polyphenol oxidase by treating fresh leaves with hot water. The major polyphenols in green tea are catechins, and the major catechins present in green tea are EGCG, ECG, EGC, and EC. It is evident from experiments that catechins in green tea inhibit the intestinal absorption of dietary lipids. Among green tea catechins, EGCG is the most potent inhibitor of lipid absorption. EGCG appears to be the most effective at decreasing the absorption of lipids, and is the most abundant of the catechins. All catechins can be found together by consuming green tea or green tea extract. Tea catechins may have a favorable effect on body composition in humans because it has been shown to reduce body fat and reduce the risk for heart disease, as well as some studies have shown an increase in effectiveness when paired with exercise or caffeine. My first three studies investigated EGCG with lipid absorption in rats. The first study focuses on the dosage of EGCG. In the study titled Effect of EGCG on Lipid Absorption and Plasma Lipid Levels in Rats, it discusses the effects of cholesterol paired with different dosages of EGCG. EGCG has been shown to reduce plasma cholesterol levels and the rate of cholesterol absorption. They tested the response based on the dosage of EGCG in Windstar rats found on a diet high in cholesterol and fat. They were separated into four groups, the control group adding no EGCG to their diet, the second group adding 0.2 grams of EGCG to their diet per day, the third group adding 0.4 grams of EGCG to their diet per day, and then the fourth group adding 0.7 grams of EGCG to their diet per day. After 4 weeks of treatment, the total cholesterol and low-density lipoprotein plasma levels were significantly reduced in the group fed the highest amount of EGCG when compared to the control group. Total fat absorption was significantly effective in the control group at 99.5%, but fell significantly as the dosage of EGCG went up. In the group treated with 0.4 grams of EGCG, intestinal cholesterol absorption fell all the way to 62.7%. The study provides evidence that cholesterol-lowering effect in green tea is mostly by EGCG, and it is believed that the mechanism by which EGCG affects lipid metabolism is by interfering with the micellar solubilization of cholesterol in the digestive tract, which will then decrease cholesterol absorption, possibly because of higher levels of free iron, which would increase oxidation. The second study testing rats with EGCG focuses on which lipids EGCG has more of an effect on preventing absorption. A study published by the Journal of Nutritional Biochemistry investigated the green tea as an inhibitor of the intestinal absorption of lipids. Koo and New drew conclusions from their own studies along with other studies, but the goal of the studies was to determine whether EGCG differentiatedly inhibited the absorption of lipids based on the hydrophobicity in rats. They measured cholesterol, vitamin E, retinol, and fatty acids absorption in the group of rats. The data showed that EGCG lowered lymphatic output of vitamin E compared to the controls, but it did not have an effect on the absorption of retinol and only lowered fatty acid absorption by a small amount. The study found a reduction in the uptake of cholesterol, whereas it did not interfere with the absorption of less hydrophobic lipids, like retinol and fatty acids. Thus, EGCG may explain the lack of absorption for cholesterol and vitamin E, and the moderate or no effect of EGCG on less hydrophobic compounds like retinol and fatty acids. This study also found that EGCG prevents pancreatic phospholipase A2, and that this green tea catechins may reduce the risk of heart disease. The inhibitory effects of EGCG appears to be associated with its ability to form complexes with lipids and lipolytic enzymes. interfering with the processes of emulsification, hydrolysis, micellar solubilization, and in the end, absorption of lipids. EGCG appears to be more effective in lowering the absorption of lipids of extreme hydrophobic lipids and with moderate effect on less hydrophobic lipids. The final study testing rats on EGCG focuses on EGCG with caffeine and tea for prevention of absorption. The goal of the study was to determine whether EGCG and caffeine have an effect on the intestinal absorption of cholesterol and other fats. 20 female rats were tested on for 2 weeks. The rats were split into 4 groups: the control group, the group receiving EGCG, a group receiving caffeine, and a group receiving EGCG and caffeine. Each rat received the same amount of lipids mixture and weighed the same when they started the study. The total absorption of lipids and the lymphatic output of esterified cholesterol was significantly lower in EGCG, caffeine, and EGCG plus caffeine rats compared to the control rats. Also, EGCG and caffeine significantly lowered the absorption of vitamin E. Caffeine seemed to also lower the amount of lipid flow, regardless of whether it was used with EGCG. This concludes that the results indicate that both EGCG and caffeine inhibit lipid absorption, and that the inhibitory effects on the two components of tea are not synergistic because they are not based off of each other, but they can be mediated by different mechanisms. My last study investigated green tea extract and green tea with lipid absorption in humans. This study followed obese subjects with metabolic syndrome, and the goal of the research was to evaluate how green tea affects weight, lipid, and lipid perioxidation in obese adults with metabolic syndrome. They used 35 adult subjects and split them into 3 groups for 8 weeks. The control group drank 4 cups of water daily, the second group drank 4 cups of green tea daily, and the third group drank 2 capsules of green tea extract with 4 cups of water daily. This showed that green tea beverage and green tea extract over an 8-week period led to a significant weight loss in obese subjects with the metabolic syndrome compared to the control group. It also showed that green tea beverage further lowered lipid perioxidation and lipid absorption versus the control, suggesting the role of green tea flavonoids in improving features of metabolic syndrome in obese patients. This is actually the first study that shows a major beneficial effects of green tea beverage and green tea extract supplementation on cardiovascular risks in obese subjects with metabolic syndrome. But more research is needed to be figured out how this process works and how the correct dosage would work for each person. So did we find a common conclusion among all these articles? I believe so, because in each article, EGCG has some sort of effect on lipids, in particular lipid absorption. The final article did not make a conclusive connection between EGCG and lipid absorption, but it concluded major weight loss in its subjects, which may be caused by lack of lipid absorption. The studies are not only in their early years of development, but there are currently only a handful published. Therefore, a decisive conclusion cannot be made. But from the evidence laid forth, EGCG in green tea and in green tea extract affect lipid absorption by decreasing it.